In this video, we will discuss about search insert position. So first, let's understand the question. Given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. You must write an algorithm with log and runtime complexity. So what they are saying is that in the input, you are given an integer array in which all the numbers are in sorted order, increasing order, right? And you are given a target. You need to find out whether this target is present in this array or not. If this target is present, then at whichever index it is present, that index you need to return. And if it is not present, then if that target would have been present in your array, then at what index it would have been, that index you need to return. Meaning, if we take the target as 5 and this array, then you will see 5 is present here. So in this case, your answer will be 2 because 5 is present at index 2. Then the second case, our target is 2, but in this array 2 is not present. But if it would have been present, then at what index would it be? Here, right? Because 2 is greater than 1 and lesser than 3. So this index would be 1. So that means when your target is 2, you need to return 1, right? So now it is given to us in the question that whatever algorithm we are going to write, that should have a complexity of log n, order of log n, right? And in the array, all the elements are sorted. Now, keeping these 2 points in mind, can we say that we can solve this question using binary search? Because binary search has two main points. First is the elements are sorted, right? In binary search, the elements are sorted and its time complexity is order of log n, right? So that's why we can use binary search here. Now, when do we apply binary search? When we need to find an element in our array, right? When we will apply binary search for an element, it will return us the index of that element, right? So first of all, we are taking the case where our target is present. Then we'll see what are we going to do in the cases where the target is not present, right? So how do we apply binary search? So we create two variables, L, which denotes our extreme left, and it is initialized with the lowest index, which is 0, and R, which denotes right, that is the extreme right, and it is assigned the last index of your array, which is 3 in this case, right? Then what we do is we run a loop while L is less than equals to R. Then inside this, now we calculate the mid. So for mid, we do L plus R divided by 2. Now in some cases, we use this formula left plus right minus left divided by 2. Now this formula is used when the value of L and R is very large, because when you will use L plus R divided by 2, in that case, if L and R value are very large, then you might get the error of integer overflow. But if you will use this formula, then it will reduce the value, so you won't be getting the integer overflow. In our this question, the maximum value of NLR is given to us as 10 to the power 4, so you can use any of them, right? So then we calculate the mid. After we have calculated the mid, we compare it. We compare that if our array's mid is equals to the target. If it is, then we simply return the mid, because mid here denotes the index of that target. Else, if your nums of mid is greater than the target, if it is greater, then that means we will have to move towards the smaller numbers to find our target, right? That's why we reduce our R. So we do R equals to mid minus 1. Otherwise, we do left equals to mid plus 1. So at the end, when our target is present, this condition will be true and this will return the mid, right? Now coming towards the case where our target is not present, right? In that case, what will happen? Let's dry run this code over these two test cases. So let's remove this. So our target is 2. So initially the value of left is 0 and the value of R is 3, right? So now is 0 less than equals to 3? Yes, it is. So it will come inside. What will be the value of mid? It will be 0 plus 3 by 2, which is 3 by 2, which is equals to 1. So now what is the value at 1? It is 3. Now is 3 equals to target 2? No. So it will come here then. So is 3 greater than 2? Yes, it is. So we'll do R equals to mid minus 1. So now your R will become mid minus 1, which is 0, right? Now it will again come inside. Is 0 less than equals to 0? Yes, it is. What will be the value of mid? 0 plus 0 divided by 2, which will be equals to 0. So now is your nums of mid equals to target? Nums of mid is 1 and target is 2. So these are not equal to. Then you will check this. Is 1 greater than 2? No. So we'll come in else and we will increment L. So now L will become mid plus 1. Mid was 0, so L will become 1. Now L is 1 and R is 0. So is 1 less than equals to 0? No. So this loop will stop. We will come out of this loop. And when we came out of this loop, L was having the value as 1 and R was having the value as 0. Now if you see here, if 2 would have been present in this array, then at what index would it be present? 2 would be present at index 1, right? And if you see here that our variable L is pointing to index 1 only, right? So can we say that when we get out of this loop, then whatever is the index in L, that will be the index where our target would be present. Let's verify it with another example, which is 7, right? So in this, initially the value of L will be 0 and R will be 3. Then is 0 less than equals to 3? Yes, it is. What will be your mid? 0 plus 3 divided by 2, which will be 1. So at index 1, we have the number 3. Now, is 3 equals to 7? No. Is 3 greater than 7? No. So we will increase the left. So now left will become mid plus 1, which is 2. Right now, is 2 less than equals to R? Yes, it is. Now, what will be your mid? 2 plus 3 divided by 2, which will be 5 divided by 2. So, it will be equals to 2. So, mid is 2. Here, the value is 5. Now, is 5 equals to 7? No. Is 5 greater than 7? No. So, it will again come in else and we will increase left. So, the value of mid was 2. So, now left will become 3. So, now it will check, is 3 less than equals to 3? Yes, it is. What will be the mid? 3 plus 3 divided by 2, which will be 6 by 2 and 3. So now nums of 3 is 6. So is 6 equals to 7? No. Is 6 greater than 7? No. So we'll come in else. So we will increase the L. So mid was 3. So L will become mid plus 1, that is 4. Now in this case, is 4 less than equals to 3? No. So we'll come out of this loop. Now if you see, L is having the value 4. And if this 7 would have been present in our array, then it would be present at index 4, right? So our answer will be left. So once we get out of the loop, we will simply return L because L will denote the index of that target which is not present right now in our array. So now let's code it out. So first of all, we'll create two variables left and right whose initial value will be L and R's initial value will be nums.size minus 1, right? Then we'll run a loop while L is less than equals to R. We calculate the mid equals to L plus R divided by 2. Then we'll check if nums of mid is equals to target. Then we will return mid. Else, if your nums of mid is greater than target, then we'll do R equals to mid minus 1. Else, we'll do L equals to mid plus 1. And at the end, we will return L. So now let's run this. So in this case, our time complexity will be log n only because we have simply applied binary search. So now let's submit this. So it got accepted. Thank you so much for watching.